In this video, I'm going to solve this second order homogeneous differential equation that has constant coefficients and it has complex roots. And the differential equation is here, y double prime plus 6y prime plus 10y is equal to 0 with initial condition of y of 0 is 2 and y prime of 0 is 3. So at first, I'm going to make the assumption that our solution has this format. Y is equal to e to the power rt, and that leads to y prime is equal to r e to the power rt, and y double prime is equal to r square times e to the power rt. Now we plug in these values into this differential equation to get the following, which is r square plus 6r plus 10 times e to the power rt. I just factored out the e to the power rt, and that should be equal to 0. Now, this function e to the power rt is an exponential function, hence it cannot be 0. So the other quadratic function should be 0, right? So this is equal to 0. So that leads to r square plus 6r plus 10 is equal to 0. And we can solve for r using the quadratic formula, which is r is equal to negative b plus or minus square root of b square minus 4a times c, all of it divided by 2a. Here a is the coefficient of r, so a is 1. A is the coefficient of r square, which is 1, right? B is the coefficient of r, which is 6. And c is the constant term, which is 10. So if we plug in these values, what do we get for r? So negative b means negative 6, right? Plus or minus square root of b squared. B is 6, so 6 squared is going to be 36. Minus 4 times a is 1. So 4 times 1 times c is 10. All of it divided by 2 times a, or 2 times 1. So it's going to give me r is equal to negative 6 plus or minus square root of 30 minus 40, because 4 times 1 times 10 is 40. So it's going to give me square root of negative 4, right? Which, by the way, is nothing but I times square root of 4. All of it divided by 2. So r is going to be equal to negative 6 plus or minus I times square root of 4 is just 2, right? All of it divided by 2. That gives me R1 is equal to negative 3 plus I, and my R2 is going to be negative 3 minus I. So I have my R1 and R2. So now let's go ahead and find the solution. So my y1 is going to be e to the power r1t, or e to the power negative 3 plus I, and similarly y2 is going to be e to the power, okay, so I have to multiply it by 3, negative 3 plus I times t, and y2 is going to be e to the power negative 3 minus I times t. Now I kind of need to simplify these guys. So if I simplify it, let's go ahead and write it out. This is going to be nothing but e to the power negative 3t times e to the power it, right? So that's going to be e to the power negative 3t times cosine of t. So this is going to be the Euler's formula. So it's going to be cosine of t plus I sine of t. So if I distribute the e to the power negative 3, it's going to be e to the power negative 3t times, I should put the I here, times sine of t. Similarly, if we simplify this one, I'm going to get e to the power negative 3t times e to the power negative it. Only difference is going to be just the sign here. Instead of this being plus, it's going to be minus. So e to the power negative 3t times cosine of t minus I times e to the power negative 3t times sine of t. So these are my solutions, y1 and y2. So I can write the general solution in this format. So let's say y of t is one of the solutions. So it's going to be, let's use k1, some constant, times y1 plus k2 times y2. If I write it out, it's going to be k1 times this whole thing, right? So e to the power negative 3t cosine of t plus I times e to the power negative 3t sine of t. Then plus k2 times e to the power negative 3t cosine of t minus I times e to the power negative 3t times sine of t. Now, these k1 and k2 are some constants. So, as we know, because y1 and y2 are solutions to the given differential equation, so any linear combination would also be a solution that you already know. So now I can just kind of do a little bit of manipulation. This technically should be a solution, fine. However, we kind of want to get real solution so that we can get rid of the i's, and that could be done by just doing slight manipulation of the coefficients k1 and k2. If I assume k1 is equal to k2 is equal to 1/2, then this is going to give me a new function, which let's call it u of t, that is going to be equal to e to the power negative 3t times cosine of t. And similarly, if I assume k1 is equal to k2 is equal to 1/2 times I, that's going to give me, let's say, a new function, call it v of t is equal to e to the power negative 3t times sine of t. So now you have this solution and this solution. And by the way, here is something you can do to show that these guys are linearly independent. You can find the Wronskian. So finding the Wronskian of this u and b, u of t, comma v of t, is going to be just basically finding the determinant. So determinant of u prime and v prime, and that should be pretty easy. And if you do it, you should get a number that should be not equal to 0. So having said that, now let's go ahead and get our final solution. So my final solution without the imaginary parts is going to be y of t is equal to c1, some constant, right, times v of t plus c2, sorry, I meant c1 times u of t. It really doesn't matter, I can switch it around, but c1 times u of t, c2 times v of t, or y of t is going to be c1 times u of t. What is my u of t? E to the power negative 3t times cosine of t plus c2 times e to the power negative 3t times sine of t. Now we got to find the constants c1 and c2, and we can do so by just plugging in these values. So this one, y of 0 is 2. So if it is 2, it's going to be just 2 is equal to c1. I'll tell you why c1 is 2. E to the power 0 is going to be 1. Cosine of 0 is going to be just 1. But sine of 0 is 0. So that's going to vanish the second term. Now to find the c2, we need to take the derivative of y. If you take the derivative, you will get this. And then if you plug in the value y prime of 0 is equal to 3, you're going to get 3 is equal to negative 3 times C1 plus C2. All right. We found C1 to be 2, right? So it's going to give me 3 times negative 3 times 2 is 6. Then if you move it to the other side, that's going to give you C2 is equal to 9. So that's going to be equal to negative 3 times 2 plus C2, or C2 is equal to 9. So I found C2, I found C1. Now my final solution is going to be y of t is equal to C1, which is 2 times e to the power negative 3t times cosine of t, plus C2 is 9 times e to the power negative 3t times sine of t. And this, by the way, is your solution, okay? Solution to this differential equation with the given initial conditions. I hope that this discussion was helpful. Thank you very much.